Now we'll see some really cool application of propositional logic, and that is Boolean algebra. Boolean algebra are used to encode circuits, and circuits in turn are used to build up electronics. So your entire computer is built out of the principles of Boolean algebra. So what is Boolean algebra? It is the algebra just like your regular algebra, with few very subtle differences, actually major differences. Firstly, the only numbers allowed are 0 and 1. So unlike all real numbers or natural numbers, we only allow 0 and 1. And the operations, the only operations allowed are addition, multiplication, and something we call changing the sign. I've written it like this. It'll become clear in a moment. But now, what are the rules of addition? Like, what do we do if we have to add 1 and 1? Because there is no 2. The only numbers are 0 and 1. And here's where propositional logic comes in. The numbers 0 and 1 actually correspond to false and true. And the three operations correspond. Plus corresponds to taking or, multiplication corresponds to taking and changing the sign corresponds to negation. So that's it. The rules of Boolean algebra are exactly the rules of propositional logic. And let me explain by examples. Say I wanted to do 1 plus 1. Then in logic, this is doing true or true. Now I know that true or true is true. And so I'll get that 1 plus 1 is 1. That's it. Let's say I wanted to do 1 times 1. Or let me do 1 times 0. Then I'll get 1 is true, 0 is false, and times is and. And I know that true and false is false, and false is 0. So 1 times 0 is 0. As simple as that. You already know how to do Boolean algebra. You just get it as a bonus from doing propositional logic. Now the last thing about changing the sign, the way it's written, or it's also called conjugation, the way it's written is as it's on the top of something instead of writing it as negative on the side. That's just a convention that's followed in Boolean algebra. And 1 is true. And when you negate true, you get false. And false is 0. So that is saying conjugation of 1 is 0. And similarly, conjugation of 0 is 1. You similarly get laws of Boolean algebra, which completely mirror the laws of propositional logic. And again, you don't have to memorize any complicated ones, just the basic ones. So for example, you will get a double negation, so law of double negation, which for logic, it says not P is P. And for us, it will say, if I take a variable X, which is either 0 or 1, and I conjugate it, and then I conjugate it again, then I will get it, same thing back. Similarly, I'll get De Morgan's laws, which say that if I take not of and, then it becomes or. So this will look like and for me is multiplication. So if I take multiplication and I take its not, which is conjugation, then that will become something like that. And similarly, if I were to do addition and take its conjugation, it will turn into multiplication. So Boolean algebra is weird, but it's weird precisely because it is not actually algebra, it's secretly propositional logic. And that's really is. There is really nothing more to say about Boolean algebra. If you can do propositional logic, you can do Boolean algebra. In your head, you should just change all the multiplications to ands, all the pluses to ors, and all the conjugations to negations, and just solve it as if it were a propositional logic problem. That's it. Very easy. You already know how to do it.